Yay.
Can you, while you do it?
I might save it till after. Thank you.
Okay. Jaden, we are live.
Okay. So, Kip, we had two questions. One question is, what level do you think high school shouldn't? Oh, wait. What level of math do you think high school students should be required to take? And do you think math is taught in the appropriate order? And that is from Angie. That is my lovely wife.
What do you think?
Um, well, I'm going to start with the second part of that. Do you think math is taught in the appropriate order? Um, so over that past couple years, they've changed some things up in the math core, at least in Utah. And it is kind of weird because I've been working in like middle school math for a little bit and helping tutor some students, and they try and fit a lot in a year, but it's all like base level stuff. So it's not too difficult for the students, but it's just a lot of different types. So a little algebra, a little geometry, a little this and that. And I think that's kind of weird, but maybe it will work out. I don't know. What do you think, Kip?
Um, I don't know, Jaden. I haven't been in school for a while. I think that the order for the most part is all right. But I feel like the way in which people teach math is not very useful. Um, they teach people in such a way that I feel like by the time you get to college, you have a lot of math knowledge and you know how to write a lot of equations. But something
Okay.
as simple as understanding what a graph is and what it represents, or what an equation actually represents, they don't know, right? They know how to find the y-intercept, but they don't know what a y-intercept even means. But they're really good at finding one, right? But
Right.
they don't know how it applies to their lives, and I think that that's something that I struggle with. Is I have a lot of when I tutor students, they just are looking for the answer, and math would be so much easier for them if they understood that there was actual physical values or properties behind this math.
Right. It's a lot more useful than just getting the answer and the grade that you want, right?
Right.
Um, so I would agree with you where teachers can definitely teach math in a more a different way that makes people understand it and where we can actually apply it in our lives a lot more than what you see now. Um, Looking at the first part of the question, what level of math do you think high school should students should be required to take? And give us why that is.
Um, I think I mean, what level of math should students be required to take? I think that that
Yeah.
one is dependent on, in some aspect, on what it is you're going into. I think the level of algebra that they make you take up through a high school is a little more than I feel like what most people will need to learn in their lives. Um,
Yeah.
and so it's a tough question because, part of that structure, I feel like it does build on itself, but it's not necessarily all useful things that students will need to learn for the rest of their lives. Things like, I guess, that would be more useful and maybe you should have more courses based on those, or things involving taxes or more
Okay.
applicable types of math.
More on the financial side than on the theoretical side of math.
Right. For me and you, we use that math that we learned in high school all the time, and it's very
Right.
useful for us. But for a lot of people out there, it's really not that useful unless they're trying to, I don't know. It depends, I guess, on what it is they're trying to do. But for the most part, people aren't trying to solve, multivariable equations on a daily basis. So,
Right. I think one thing that is valuable with those higher algebra classes that you find in high school is the skill of just solving problems. Uh, Solving problems, you have to think about it, right? And solving problems is throughout your whole life, right? Whether it be math or anything in your life. So I think that's one skill that is pretty valuable with just all math classes. So
um,
I don't know if
I, yeah, I
that would
definitely
change
agree, but
anything.
I think part of the problem with how they teach math, and this goes back to it, right, is that I don't feel like a lot of students learn how to problem solve through it. They are simply
Yeah, that's
taught formulas and then just simply told to do it. Um,
yeah, that's
so
fair.
so I think that that's where the curriculum needs to change. Students and teachers alike need to be more okay with failure, right? I think that they need to
Yeah.
allow their students to fail. I hate when I get a student, who has a math test or something like that, and it says, solve this by using this method. And to me, it's like, well, that defeats the purpose, right? Because
Yeah,
it's like,
there's a lot of
what?
ways to
There's a
solve
lot. There's a
problems.
lot of ways to do it. So why are you forcing them to do it the way you want them to do it? That you feel like is
Right.
the best. But I'm just curious, as we're sitting here talking about this, we got no one in the chats talking, so I want anyone that's viewing this, I want to hear your guys' opinion as well on what is actually what you guys feel, whether or not things need to change in the way they're taught math. If you guys liked math while you were in high school, if you currently like math, or where you guys are at with that. But just something, if you guys want to chat it up, you can go ahead and do that.
Yes, please do. Ask questions, ask other opinionated questions, right?
Yeah.
My my ideal world for the first part of the question, what level of math, is calculus. Everyone takes calculus.
I
That's just
agree with
my
you. Well, I think that I mean, to some extent, I mean, I don't think a lot of people will ever use it necessarily, but I
yeah.
think that their understanding of the universe all of a sudden will make a lot more sense. A lot of people, that I've talked to, and myself included, feel that way. It's like once you get to calculus, it's like this big aha moment.
Oh yeah, if you can understand some of the stuff in calculus, it's just really cool. Like you said, it's just this aha moment, this your brain kind of just like it just gets bigger. Like
All of a
it's
sudden,
just
the Earth makes sense. So any of you out there that want to, you know, go um, study calculus, please do. We got some comments that came in. We've got Carsey loves math, and I think that's supposed to be sarcastic. And we also have, I like what you guys are saying, go write the curriculum. So maybe we should become curriculum writers, me and you. See what it will
yeah.
be like.
Kip, what would your ideal like teaching style be? Like teacher explains like the concept, shows you the equation and then does a couple problems with you, or does your teacher take you outside, go out in the real world with a whiteboard in every student hand and start doing like stuff like that? Or I don't know, what's your ideal teacher?
Uh, I don't know. I think part of the problem is every student is different, right?
Right.
Kids learn in different ways. And so I think you have to kind of look at all the different ways out there and try to do a good mix of them. I think that hands-on learning is very useful. So if you are showing real world problems, whether that be through videos or actually hands-on learning, whatever, I think that that is a really useful way to get kids involved and to understand. I had a math teacher in college that I really liked, and it goes back to that problem solving thing. And what he would do is he would write a question on the board, and he hadn't taught us anything at all. And he would say, "Okay, solve this." And
Oh,
that's how his
cool.
whole class went. So we'd sit there and we'd try to figure it out, and he'd let us do that for about 10 minutes. And then he would go, "Okay," and then he would do one or two steps, and he'd say, "Okay, now solve it from here." And so he would
Okay.
keep doing that over and over. And so he actually made us think through the problem first ourselves, even though we had never been taught how to do this kind of stuff. And it was actually for, an extremely difficult class in my opinion, which is partial differential equations. So it was a class that was very difficult. Um,
Oh yeah,
so anyways,
that's a good one.
but
Got
yeah,
some
and
of
so
those wave equations.
yeah, lots of wave equations. We got some more comments. One from someone says that calculus for me, calculus was more of an uh-oh moment instead of an aha moment. Uh,
That's funny.
and then there was another question that says, are there more efficient ways for me to calculate taxes than simple math?
Um,
It depends on what. I mean, it is somewhat simple math, but if you're trying to get when it comes into all the tax laws and everything, you could write out a whole system of equations, a whole linear algebra thing, and try to figure out where to put your best benefits where to make you get.
yeah. And then there's like the financial side where they already have a whole bunch of equations that like accountants do for you. So that's the easiest way to do your taxes is have someone else do it for you.
Exactly. Uh, okay. So we have a few more questions here that we got to go over tonight. And one of those is we have a question about a speeding bullet, I believe, right? Shooting a bullet.
Yeah,
Do you have that question pulled up?
I have it pulled up. Yeah.
Do you want to
So
go
the
ahead and
question
make a
is,
sticky note and post it so everyone that's joining in at some point can
yeah, let me see if I can copy and paste. Copy.
And then we had another question that was left in the comments by Tristan last week asking why there was a difference in speed between the orbits of, I believe it was Venus and the Earth.
Oh, that's a good question too.
That was a good question.
Okay, can we read that? Okay. Should we make it a little bigger?
I think that's good.
Okay. So here's a question. How far will a 180 grain bullet drop at 500 yards, assuming a muzzle velocity of 3,000 feet per second? So let me first write this as 457.2, and that is meters per second.
Jaden,
Okay.
you got all pixely. Oh, there you go. You're back to normal. Phew.
So that was yards. Oh, sorry. I don't need a second, sir. My bad. That's the distance, okay, in meters. 457.2. And then the 3,000 feet per second, that's where I'll need the meters per second. And Kip, while I'm writing this down, will you explain why we want to use meters instead of yards and feet?
Because Americans are dumb and we should be using a unit system that makes more sense. That's pretty much, I mean, we could use yards and feet, but most scientists out there will use the standard units, is what they're essentially called, just because they're common throughout, the entire world. They make life easier, and most constants are calculated in SI units, and so that's normally what we use.
Okay. So there's the two conversions. Do we want to show how we got that, or do we want to just leave it as that and answer the
Dude,
question?
nowadays you got Google. That's, I think, good enough. Most people will probably just Google it. That's what I do. So
500 yards to meters, right? That's all you have to Google, and you'll
actually,
get that
I
answer.
use Ecosia. I don't know if you've heard of Ecosia, Jaden, but Ecosia is a search engine that plants trees for your searches that you do. So if you want to save the planet, use Ecosia.
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 It sounds like we're sponsored.
Yeah, for our 5 current viewers, they're all switching to Ecosia right now.
Yes. And again, if you just barely joined the stream, if you have any questions, let us know in the chat. We will try and stay on top of that.
Yeah, or send us an
But right
email.
now we are currently answering this question here. So, Kip, this seems to me like a projectile motion problem. What do you
Yes,
think?
I think it does. It sounds very much
Okay.
like a projectile motion problem. So in a classic projectile motion problem, you got 2 options. You got your y, right? And you've got
Okay.
your x component, all right? So your y component is going to be your vertical, right? How high something is going to be. And your x
Okay.
component is going to be how, I guess how far, or I mean, it's your horizontal component. So you got your vertical and your horizontal component. Okay.
Okay.
And so there's a kinematics equation that me and you derived a while back. And it's this equation right here. My thing, right? We have 1/2, or no, sorry. Hold on here. We've got VIT plus 1/2 AT squared. And then we've got the same thing here. So this is VIY, and this is AY, and this is VIX T plus 1/2 AX T squared. So what these equations both mean is this is the displacement. Oh, we need a picture. We're getting asked for a picture.
A
So
picture of the problem, like us sketch it out real quick, or what?
yeah, I think so.
Is that?
So I'm look, we got this guy and he's got a gun. Shing, shing. Oh, dude, my gun is good here. It's way bigger than he is. Dude, I'm getting a blunderbuss. I don't know what this is.
Okay.
Okay,
Sweet.
there's our bullet coming out. Thank you for that, Kelsey. It's actually going to be very important to have a picture later on.
And we want to see, we'll call this 457.2 meters. And we want to figure out how
far
right,
the
how
ball is
much
going to
it
drop.
drops.
Okay.
Like it's going to go, whee! Eventually it's going to hit the
ground.
Because gravity.
Jaden, we have to debate something here, which is, I think to start, we're going to start with this. But if you notice, this is going to make the flat earthers really happy because in this problem, we're assuming the Earth is flat. So depending on how complicated we want to get, we may have to add in something else, which may make it a little more difficult. But we might be able to use a little bit of calculus or something along the way. So we'll see how difficult and complicated we want to make things. Again, all trying to make those flat earthers, not happy. Okay. So the first thing, Jaden, that we need to do is we need to figure out what's happening, like I said, in the y direction and the x direction, right? We've got these two equations, and so let's first by starting at the y direction, okay? So when this bullet isn't getting shot at an angle, we're assuming it's being shot directly horizontal, right? So we don't, so our VIY is equal to 0, okay?
Okay, so you're saying we have a 0 velocity in our up or down direction. It's not moving up or down at all. We're just assuming straight out of the muzzle.
Right. So at start, straight out of the muzzle, it's just holding steady, okay? And so its initial y velocity is 0.
So that means we don't need this.
Yes, exactly. We don't need that. That goes away, and for you people that may not understand why, because 0 times anything is always going to be 0, okay? So the velocity times time is going to be 0. Sorry. I got a message asking when we were going to be solving this problem. Okay, so.
Wait, from the person that asked this question?
Yeah.
Oh. Did you say right now?
Yeah, I said right now. Okay, we'll keep going and figure it out from there. Okay, so. All right, so then from there, what happens? So what else do we have? So looking at this equation, we have a 1/2, that's a constant, right? That's not going to change no matter what's going on. And then we have acceleration. So let's figure out what that is. Is there an acceleration acting on this object? Well, for our sake, we certainly hope so.
Yes.
Because if there wasn't, it's not going to drop, right? And this question is specifically asking for the dropping. So there is a force that's acting straight down, right? And this is the force of gravity, Fg, not, that looks like a K, Fg. Okay. And if we remember, our force is equal to ma, right? And so our acceleration is just going to simply be the acceleration due to gravity. So our ay is going to equal negative, because it's pointing down, 9.8 meters per second, okay? And this per second squared. And this is something that is a constant, like I was talking about. You just look up, or if you've done these enough, you know what that is. This is the acceleration due to gravity at the Earth's surface. Remember, we talked last week about how that changes the further away we get from the Earth. But at the Earth's surface, this is what it is, and we're close enough to the Earth's surface that we don't have to worry about anything, and we just call it this. All right?
Right.
Okay. So, and then we have a t squared, and the t is our independent variable, and so we just leave that alone for now. So our
Right.
new y equation is going to be y equals 1/2 a negative, because we have that negative, right? 9.8 t squared. Jaden, do you want to take a turn on the x side?
Yeah, we can take a turn on the x side. So we know the displacement we want, right? So we know our x value right away because we have the 500 yards or the 457.2 meters. Okay. So that's how far we're going to go. We know our initial velocity because we are assuming a muzzle velocity of 3,000 feet per second, and that is 914.4 meters per second. We do not know our time though, right? That's what we need to solve in this part of the equation. And then we have the plus 1/2 ax. Kip, are we going to keep it simple and ignore air resistance, or are we going to throw in an acceleration that will slow it down in the x direction?
I think for this problem, we're going to ignore air resistance. Bullets
Okay,
don't have a lot of air resistance.
that is
Um,
true.
and this equation doesn't exactly hold up necessarily if we are using
Yeah.
because air resistance actually changes with velocity. Um, and so this equation, when we take the integral, it will actually be different. There will be some other factors
Yeah.
involved. So we can't just simply say that this equation would work. Um,
Yeah. For physics 1 students, our acceleration here will be 0. Right? So that means we don't even need this part of the equation. Boop. Okay. So
and now,
we
Jaden,
have,
we've seen that equation a lot of times before, right? That first part of the equation.
right. That's kind of like when we did a real simple distance equals rate times time. A lot of people have heard of that. Maybe you haven't, but that's something to just give yourself a real nice estimate of how long it's going to take you to go somewhere if you're driving on a freeway,
Right.
right?
So there's nothing slowing us down, right? We're gonna assume that this
Right.
bullet is in a vacuum.
Right. Uh, so then we have our x equation, which will be 457.2. That was a big two, equals our velocity 914.4, and that is being multiplied by our time. Okay, so that is what we are going to want to solve for, and that will be able to give us our final answer, which will be our y.
Yeah, exactly. Um, so really quick for those that are new to projectile motion problems, one of the most important things is to figure out time, right? Time is kind of this value that connects the x and the y together.
Yeah.
The x and y are related to each other through time. Um, and so that's why it's important, and that's why Jaden automatically knew to solve for time. It also helps that it's the only value that we can actually solve for right now. Um, but if we can figure out how long it took it to travel a certain amount of time, then from there it becomes a lot easier to figure out um, how far it dropped, right?
Right.
So Jaden, do we know what t is going to equal?
Let me get a fancy calculator out real
572
quick.
divided by 914.4 equals.
Okay, that equals just 0.500.
5 point what? Or what? 0.5.
0.5. You can just leave it at 0.5.
Okay.
And
And
that is,
yeah,
what
Jaden,
is our unit, Skip?
well, it's time, so I'm going to say seconds.
Okay.
Okay. Alrighty. Now, if we create a new page here, um, and if you
New
remember
page.
from the page before, we had y equals 1/2, a negative 1/2, 9.8 t squared. So our t was 0.5, so we have a 1/2, negative 1/2. This is equal to negative 1/2, 9.8, 0.5 squared. And then from there, this is the same as 1/2, and so we can square 1/2 to get a 1/4. So we have 1/4, so we have a negative 1/8.
Um,
Yes, Jaden, are you okay over there?
okay. So, oh, I'm on the wrong page.
Could you not hear me there for a minute? Or can you not hear me?
For some reason, you got real quiet, Kip.
Can you hear me
I
now?
don't know if that's on the stream or not.
Can you hear me now, or am I still really quiet?
Can you still hear me?
Yeah, I hear you fine. And on the stream, they should be
Okay.
hearing me fine. Can you hear me fine now?
Uh, Sorry, I might just have trouble with my audio. Keep explaining it. Yeah, we got confirmation from Kelsey. He says, no, he is good on the stream. You're both good. So just keep explaining it. I'm just gonna be an expert at reading lips, okay?
Okay. Can you hear me still, or is it quiet?
Yeah, I can barely hear you, but I'm good.
Jaden, did you turn down your volume?
Try talking.
Can you hear me?
Let me see one extra thing. Just keep going. I'll
Okay,
figure it
you
out.
keep going. All right, so now we need to use a calculator. And we go ahead and we do this, and we do 9.8 divided by 8 equals a negative 1.225.
Okay, and that is the same answer I got. And I think I can hear you better now, so we're
Okay,
good.
that's good. Um, and Jaden, what's the units for that?
Uh, that would be meters.
That's meters. So, why? So that means that for this bullet to travel 500 yards, or 400 and something
Pew, pew, pew.
meters, it's going to drop 1.25 meters. Now, the average height of an adult male is probably about 2 meters. And so from your shoulders down, you're probably you're probably at 1.75 meters. So this thing's going to be barely off the ground. It's going to be about a half meter off the ground
Ew.
by the time it reaches 500 yards.
There we go.
And I think that we're just going to say that the Earth is flat because it's such a big object and we're going such a small distance that the curvature really isn't going to affect it that much.
Yeah,
Agreed?
I agree. If you are a sniper, you might disagree.
It's the difference between shooting them in the foot or in the stomach.
Yeah. But yeah, that's a good estimate of how much it's going to drop. Obviously, with more and more math, you can make it more and more accurate. This higher math, uh, taking into account the curvature of the Earth, doing some calculus, you're going to have a different answer, but this is a good approximation for uh,
For
our
the
question.
Yeah, for the average person, this is good enough.
Yes.
Okay. So do we want to quickly go over, I mean, so the question that we had in the comments was, I'm setting up a new slide here, was simply, um, you know, why, um, it was essentially asking why different planets, orbit around the sun at different speeds, right? So why is a year on Mars longer than a year on Earth? Why is a year on Venus shorter than a year on Earth, kind of deal? Um, so if we were
Is that
to,
a
that's great. Oh wait, I got my eraser. No wonder it's not drawing. So, right, if we got here, I got the sun. Dude, I'm drawing the solar system here.
dude? That's nice.
Sun, and we'll say that. What do we want? We'll call this Venus. Is that how you spell Venus? Sure. Um,
Are you missing Mercury?
yeah, that doesn't
Whee!
matter. Dude, it's not a real planet. It's like Pluto.
Yeah, it kind of got destroyed early on, you know.
Earth. Dude, you like how I put two E's in Earth? I'm a good speller.
That's excellent.
Okay. So we'll just go to Mars because we'll just stick with the, what do they call them? The something rocks or something, not gas giants, the opposite.
The asteroid belt.
Sure.
Oh, just
I
are you
forgot.
talking about just what the
What?
four inner planets
Yeah,
are?
yeah. They're called something, I don't know what, but anyways,
Yeah,
so the question,
they're the rocky planets.
yeah. So the question was simply, why are they at different speeds, right? And we went over this a little bit last time, but you know, without any math, um, the way to think about it is that when you get closer to the sun, the gravitational force of the sun is stronger on that planet. Dude, what is that?
Those are the asteroid belt.
That's good. I like that. That's good. Okay. So the closer you get to the sun, the harder the sun's gravity is going to pull on you, which means that you're going to be falling towards the sun faster, which means if you're going to continue to escape the Earth's or the sun's gravitational pull, you have to be going faster, right? That's kind of the basic thought process behind it. And as you get further and further away, the strength of the sun is less, so you actually have to be going slower or else you're going to fall out of orbit. If you're going fast from far away, you're just going to shoot by, and that's what happens with a lot of asteroids and comets, right? They're going way
Right.
too fast and they don't get sucked into the sun's gravitational pull. They just get launched out the other side and keep
It's like a
going.
slingshot, just
Exactly.
pulling out of orbit.
Exactly. Um, so we are sitting here. We're done with our questions that people have sent us. Does anyone have a question they want to ask us?
Yeah.
And in the meantime, me and Jaden will sit here and talk about, I don't know, movie
While
things.
we have the uh, very, very, very accurate solar system drawn on our board, uh, what is the reason why we see four seasons, Kip? It can be kind of explained with orbits slash rotations of the Earth and our tilt of the Earth. Which one is what like affects it the most?
Dude, that's like the perfect middle school earth science test question right there.
Yeah, I know. That's what I was thinking about.
The answer is the tilt. The tilt of the Earth
Okay,
plays the biggest role. And no, it's not because we're tilted closer or further away from the sun, but rather the angle at which.
good clarification.
Um, so that is, yes, that's the important part, right? Is that if you have, so in winter, Jaden,
Yeah,
if I draw a line here, okay, this is the North Pole. So we're talking about in the northern hemisphere right now. So if we have
right.
sun's rays, right, um, and they're coming out like this,
Oh, we
uh,
both did it.
yeah, but yours are bent, dude. You can't have a bending ray. Rays go straight. That's
Well, I mean, both of ours like are
unless
not
there's some
straight.
serious unless there's some
So
serious gravity going on. Maybe, dude, I think we got a big mass of
there's
dark
a
matter,
black
right?
hole right here.
Yeah.
Okay,
Um,
but anyways, keep going.
so from there, so the rays are actually not hitting as much on the northern part. It's not as direct sunlight, and so it's
You can kind
colder.
of show this with a flashlight and like a piece of paper, right? If you shine a flashlight straight at the piece of paper, you see the light as like a lot brighter, a lot stronger. But if you tilt the paper just a little bit and shine it, you see how it spreads out a lot more. So the same amount of light is being spread across a different surface area, and that affects the warmth a lot. That's just something you can kind of see yourself with simple objects around the house.
Cool.
Okay,
Thanks,
keep
Jaden.
going, Kip.
Okay, so if we rotate, right, so the Earth is spinning around, so now we get to this point, the rotation of the Earth is still the same. And so now we have this, where this is the south and this is the north. And now it's the opposite, right? So the south isn't getting as much sunlight and the north is. And that's why the seasons vary depending on where you are on the planet as well.
Awesome. That is perfect explanation. We have a question from Kelsey. It says, how would you make projectile math more applicable to students' lives?
Well, I think that depends on what the student wants to do with their life. Um, it's there's a lot of things that projectile motion is something that we as humans, you know, experience every single day from, if we accidentally drop something, that's projectile motion, or if we throw
Yep.
something, or if we jumped, those are all projectiles in motion. And so if, there's a student that's really into baseball, you could, help them calculate and figure out how far, how fast they need to throw a baseball in order for it to drop a certain amount by the time it gets to the batter, right? To really throw them off their game or whatever.
Right.
You could, use it to calculate. I don't know if you've got a runner or you've got a track athlete and they need to figure out how far they can jump, right? You can help them understand why jumping this way is better than jumping a different way. I don't know, Jaden, do you have any ideas?
Yeah, I think those are all great examples of where you can see it, right? Any sport with an object that is moving, right? Like soccer, basketball, football, baseball, all those. Um, One thing that I think would be really cool in physics classes is I'm sure some physics teachers do this, but to actually have the students do like some projectile, like actual experiments, like maybe make a catapult in class and see how far you can fling whatever object, or maybe like take the students outside if they're baseball players and have them calculate like their own pitches and like see how far it's going to drop in a certain amount of time and how fast they can throw it. So I think physics teachers could do some of these ideas and make it a little bit more fun to actually see what's happening mathematically. And I don't know, I feel like that'd be a cool class.
Yeah, that definitely would be. I think another thing that I just thought of that, um, one of the things that I feel like a lot of times you hear are things like art students saying that they'll never need to know physics or they don't need to know math, right?
Oh
Um,
yeah.
but one of my favorite mediums is animation, right? And
Oh,
animation, you have to make things look realistic. Um, and so you could actually do the calculations if you have 30 frames a second, how far something, if you have, someone throwing something, right? How far that object is going to travel in a certain amount of time. So it's actually accurate. Um,
right.
and so in animation they're constantly talking about making things look realistic and how to physically draw that, and so you could actually calculate that out. And when you get into 3D animation, they actually do a lot of that. They have a lot of physics simulations already built in. They have gravity functions
Yeah.
built in and stuff to make it look as realistic as possible. But just the
Yeah.
other day, actually, I was working on a 3D animation for projectile motion because I just wanted to model it. And
Oh,
so I went in and I was able to, using frames and coding and everything, I was able to calculate projectile motion and be able to watch it in animation format, which is pretty cool.
that is super cool. Um, so maybe combining like different classes could be a good idea too. Like you said, you could combine like physics with like programming or coding and have them code some of these physics equations and see what it looks like in animation. But speaking of animation, Moana, fun fact, you know how her hair is real curly and bouncy?
Yeah.
Uh, they had to use partial differential equations to make it look the way it does. So that's just some cool fun fact about it. And
Yeah,
yeah,
well, there's a lot of math involved in animation in particular. But yeah, I think that giving students projects, and they don't need to be out of class projects, they could be in class projects, but finding something that, is interesting to them and having them go and figure out how they can use it is, I think, a really good way to do that. So,
agreed.
anything else, Jaden?
Um, I don't really think we have a lot of time to dive into another subject. So is there's any last minute questions anyone in the chat
Have you
wants
checked
to
the email
ask?
just to double check? Because I have not been looking at the email.
I'm looking at it now and there's nothing new, so we have answered all the questions. Uh, and if you think of any questions by the time we have our next live stream, make sure you email us at after.math.live.stream@gmail.com. Ask any questions you want related to physics or math, and we are happy to give our best explanation for them.
Exactly. And if you like what you're seeing, don't forget to hit the like and subscribe button down below and turn on that little bell so that you can get notified when we go live again. We go live every Tuesday and Thursday at 7 o'clock. So we're, here to help you guys out, really. That's all we want to do is help you out. So
Yep.
send us your questions, please. All right. Peace
Okay.
out.
All right.